This question begins with a graph, so we begin with Oizerga. The origin is there. Y-axis is force. The x-axis is time. The intercepts, yes, there is a y-intercept of FO. And there is an x-intercept. F equals 0 at T1. We can read force and time. The slope is delta F over delta T, or the rate of change in force. And the area is F delta T, which is the impulse J, which is equal to the change in momentum is M delta V. All right, so now we read a soft foam block of mass M slides without friction. All right, so we got a foam block, mass M, slides with no friction, positive x direction with a speed v. Time 0, a student briefly pushes the block with a force probe in the positive x direction. So it gets a push in that direction. So we expect v to increase, we expect p to increase, the momentum and the velocity. It's a collision of sorts when the person pushes it with the force probe. The force probe's measurement is a function of time. True about the block's momentum between T0 and T1. Well, without even looking at the graph, just from the situation, we know the momentum must increase. So let's look to see. Decreased, false. Increased, yes. Decreased, false. Cannot be determined without knowing the distance by which the force probe compressed the block. Not sure if that's correct, but we're down to 50-50 in any case here, just by knowing that the momentum has to increase when you're applying a force in the same direction that it's moving. Okay, so this one says the block has increased. It cannot be determined. Well, let's see if we can. If we want to know the change in momentum, the delta P is the area, and that's the area of a triangle, which is 1/2 base times height, and that is 1/2 T1, and the height is FO over 2. Oh, excuse me, is 1/2 FO. 1/2 the base, T1, times the height, which is FO. So that looks like this. If we also could do it as an area of a rectangle, where we would say it's the height, the length times width, and the length is T1, and the width is FO over 2. Get the same answer in either case. And so clearly we definitely can tell. False. And we didn't need to calculate it to do that, because just by doing this RGA analysis, we can find the change in momentum by finding the area. So we could eliminate this and never even have to solve for this. The other three are just purely incorrect because we can tell and it doesn't decrease. We know it increases. So that's enough right there.